Mechanical waves. Mechanical waves need, of course, matter to transfer energy, or a medium. There are two different types of mechanical waves. There is longitudinal and compression. Examples include sound, water, earthquakes, and even people. Magnetic waves or electromagnetic waves. They can also be mechanical waves, but not always. There are two different types of magnetic waves. There are radio waves and microwave waves. Examples of this include accelerating electric charges, vibrating electric and magnetic fields. Longitudinal waves. These waves in which the direction of propagation align with the direction of vibration of the medium or the matter. Examples of these type of waves include sound waves and even ultrasounds. Compression waves. A mechanical wave where the medium or the matter moves forward and backward along the same direction that the wave travels. Examples of this also includes sound waves. So first we have the wave anatomy, starting with transfer waves. The first section of the wave is the crest and trough. The trough being the gap in between each wavelength. The crest is the highest and lowest points of the wave. Next, we have the wave height. As you could probably guess, the wave height is the vertical distance between each crest. This is determined by the amount of energy of the wave. The last thing on this graph is the wavelength. This measures the distance between each crest horizontally, and this is determined by the frequency of the wave. Compression waves. The second wave type we have is the compression wave. This is similar to the transverse wave. This wave type also has a wavelength, but is measured between each compression, which is the parts of the wave that are, you guessed it, compressed or close together. The parts in this wave that are farther apart are called the expansions. Period. The time it takes for one complete cycle of that event to occur. Frequency. Frequency describes how often a repeating event occurs per unit of time. The wave equation is, of course, V equals F times wavelength. V standing for velocity, or otherwise known as speed. F stands for frequency, which can also be an alternate for period, depending on the equation in the problem. And the symbol right there is going to, of course, stand for the wavelength. You can also put this together into a triangle, kind of similar to density, mass, and volume. It'll help out in the long run when you're recording a problem. In conclusion, this is the anatomy of the wave. Hope to see you again and talk to you next time.